field of view. Field of view. What does it mean? Field of view in the sense, it is the region where the diverging rays coming from the object or the image are present, taken to be field of view. Field means the region where the diverging rays must present in order to see the object or the image. Suppose an observer wants to see the object or image, definitely the light rays must incident on eye of the observer. That is possible whenever the light coming from the object or from the image. If the light is coming from the object or the image, definitely it is taken to be diverging light. Therefore, the region where you are observing the object, the region from where you are observing the image, the light must be diverging, which is coming from the object or the image, which is taken to be field of view. Let us go for an example. Let us consider one plane mirror. This plane mirror, from this plane mirror, an object is kept symmetrically. Here object is keeping symmetrically. This is object. Okay. Now, a ray of light incidenting on this plane mirror. After reflection, and they are extending. This is image. Right, this is object and this is image. This image is virtual image. The light undergoes reflection. This is the region. This is the region where the observer is presented. Observer is anywhere else in between these two boundaries. Yeah. He can able to see the image. Suppose this observer is just outside of this boundary. He cannot see the image of this object in the plane mirror. Not possible. Therefore, field of view is also one of the very important concepts in order to see the object or the image, for which what we need a divergent light which is coming from object or the image. The diverging light is not spread throughout the space. That will be spread to a certain region. In that region, if an observer is present, he can see the image or he can see the object. The same thing here. This is diverging light. The boundaries are given limits in which the observer is there. He can see the image of this object when he is presented anywhere in between these two boundary lines. So this is known as field of view. Field of view. In case of a refraction, suppose this is by the reflection. In case of refraction, we can also get field of view. The light rays undergoes refraction and giving finally here image. So this portion is taken to be field of view. In this region, person is presented. Then he can able to see the image. This is image, this is object. This is by refraction and this is by reflection. So in both the cases, these regions are taken to be field of view. I remind once again, the field of view means this is the region where the divergent light which is coming from the object or the image present. Then the observer can see that image or the object. Otherwise he can't see. By this example I was clearly explained that if an observer is outside of this region, he can't see the image. Okay, so this is called field of view. But there are two specified points and focused points. I would remind those focused points. Point number 1. The field of view range is deciding by the extreme reflected and refracted light rays. Keep in our mind. The boundary, the region, who decides this? The field of view has its own boundaries. The field of view has a boundary lines. That region, the finite region, who decides? That is decided by the extreme light rays which are reflecting, or extreme light rays which are refracting. See here, these are the incident at the boundaries. It is boundary where it is incident and getting reflection. This is extreme reflected light rays. And so many light rays are incidenting in between and they are giving reflections, but they are not extreme, they are not deciding the boundaries. The boundary can be decided by the extreme reflected light ray or extreme refracted. Of course, the light ray incident here, this cannot be decided. Here, this cannot be decided. So here it is incident at these locations, that cannot be decided the field of view. The range cannot be decided by other than these extreme light rays. They cannot decide. This region can be decided by the extreme reflected or refracted light rays. This is point number 1. And point number 2 is, it depends on the position of the object. Object position changes, the field of view will also be changed. Its range will also be changed. How we can understand this? I will show in this diagram. See, this is whenever the object is at this situation, at this position, the field of view is this part. This is field of view 1. Field of view 1. Okay, next, if object is keeping closer to this mirror here, now what happens? The light incident here. See one more point. A normal is drawn over here. So this is angle of incidence. Say it is 30 degree. This is also 30 degree angle of reflection. Suppose object is keeping closer, then extreme light ray, now with the normal angle of incidence 60 degree, and corresponding angle of reflection will also be 60 degree. That must be 60 degree. This is 60 degree. And similarly here 60 degree with the normal and undergoes reflection. See here, this boundary line is extended from here to here. The field of view is increased. Field of view 2, second field of view is greater than that of first field of view, that depending upon the position of the object from the mirror or the lens. So here there are two focus points. We should remind them. First one is the range is decided by the extreme reflected and refracted light rays. And the second one is, it depends on the position. Means the field of view is decided by the position of the object. Whenever the object closer, then field of view is increases. So far away, field of view decreases. So this is field of view concept. Next, go for its relevant problems. Field of view, relevant problems. Example. Let us consider a plane mirror. An object is keeping symmetrically to this plane mirror. This is object keeping at a distance of L, and length of the plane mirror is D. A person is moving parallel to this plane mirror along this line at a distance of 2L. The range up to which this person can see the image of this object in the plane mirror is. This is the question. Once again I repeat. There is a plane mirror of length D. An object is keeping symmetrically to the plane mirror at a distance L, and a person is moving parallel to this plane mirror at a distance of 2L. Find the range up to which this person can see the image of this object in the plane mirror. Okay, let us find it. It is quite based on field of view concept. See, the light incidenting on this mirror undergoes reflection, extending them, and you will get image over here, virtual image. Distance of the object L is equal to distance of the image. This is also L. Okay, so this is I, this is A, this is B, this is M dash. Now I M dash, I A B are similar triangles. I M dash and I A B are similar triangles. Therefore, D by, or otherwise we can take AB. We are finding this one, AB. How much? AB by D. Ratio of corresponding sides. So this is from here to here. This is L plus 2L. 3L by this is L. Let's cancel. AB is equal to 3D. So this is the range up to which this observer can see the image of this object in the plane mirror. What is that? 3 times that of length of the plane mirror. Up to that range he can see the image. This is problem number 1. And one more problem relevant to this field of view. Let us move on it. Problem number 2, based on the field of view. Let us consider a plane mirror. Its length is 2 meters, which is kept at a height of 12 meters from the ground. Means its lower edge is keeping at a height of 12 meters from the ground, and an object is keeping symmetrically to this plane mirror at a distance of 0.5 meters. 0.5 meters. Now, a balloon is moving vertically upward. This is a balloon moving vertically upward with a velocity 20 meters per second. At a distance, it is moving parallel to the plane of the mirror at a distance of 5 meters. As it is moving upward with this constant speed at a height of 14 meters, a person drops from the balloon himself at this height. then he will move under gravity. He will move under gravity. Find the time for which that fellow will observe the image of this object in the plane mirror. What is the time for which the observer can see the image of this object in the plane mirror? Or how much time the person will observe can see the image of this object in the plane mirror? So that is the question, right? So here the light is incidenting. See, this is object incidenting on it, and it is also incident on second, undergoes reflection, and this is its image. This is image. Now let us find this. Whenever the person is dropping from the balloon at this position, this fellow has its own speed. Whatever the speed the balloon has, that speed is 20 meters per second upward. Now he will move upward to a certain extent and again coming back, moving under gravity. So whenever he is moving, this is field of view. So when we take the extreme reflected light rays, then deciding the field of view. In this field of view, as long as this fellow is present in this field of view, he can able to see the image of this object in the plane mirror. Okay. Now, for what time he will be in this field of view? From here to here, time. Again coming back, return journey, and again moving up to here. So we have to find from here to here time, and from here to here time, and from here to here time. So let us consider this is a point P, and this is A, and this is B. So P to B and B to P, time will same. Suppose T1 and return journey T1, total 2T1. And from P to A, this is T2. Let us find these two, T1 and T2, you will get its answer. Alright? So first go for this one, field of view. This is AB. AB by the ratio of corresponding sides. These are the similar triangles. AB by, this is 2 meters. AB by 2 is equal to this distance total. Distance, this is 0.5, here it is 0.5. 0.5 plus 5, this is 5.5 by, how much this? From here to here, this is also 0.5. Because distance of the object equal to distance of the image, 0.5, 0.5, right? This is also 0.5. Now AB is giving us 22 meters. 22 meters. In this 22 meters, this is already known value, 2 meters, and this is also 2 meters, and remaining this is 10 meters, and this is also 10 meters. 10 meters, 10 meters. Why these two are equal? Here the object is keeping symmetrically. This is angle of incidence, this angle of incidence, both are equal. Therefore these two are equal, corresponding these gaps are equal. Therefore this is 10 and this is also 10. So let us find the first one. So this is using S is equal to ut1 minus half g t1 square. S is 10 meters. Here initial velocity of the person is 20 t1 minus half g 10 t1 square. So this is simplifying. This is 5, 4, right? T1 square minus 4T1 plus 2 is equal to 0. And simplifying this, T1 is equal to 4 plus or minus root over 16 minus 8 by 2, which gives us 4 plus 2 root 2 by plus or minus by 2, which gives us 2 minus root 2, which gives us 1.414. So simply it is 0.589, or roughly it is 0.6, that will be 0.6 seconds. Okay, so from P to B 0.6 seconds and return journey same time. Therefore T double 2T1 value. This is say capital T1. How much? 2 into 0.6, which gives us 1.2 seconds. And from P to A, what is the time taken? P to A downward motion. Again use S is equal to U T2 plus half G T2 square. Why it is plus? It is moving downward motion. So this is from here to here 2 meters, from here to here 10 meters, 12 is equal to, this is 20 T2 plus 10 5 T2 square, and quadratic equation 5 T2 square plus 20 T2 minus 12 equal to 0. By solving this you will get T2 is equal to 0.53 seconds. Now the total time T is equal to capital T1 plus small t2, which gives us 1.2 plus 0.53, which gives 1.73 seconds. During this time, he can able to see the image of this object in the plane mirror. So this is a very important and very good problem. So related to field of view, right? The next, let us move on. One more problem. That problem is let us consider a plane mirror. Its length is 2 meters and a vertical pole is keeping on the ground. A pole is keeping on the ground. Its height is 4 meters and which is keeping parallel to the plane of the mirror. Which is keeping parallel to plane of the mirror at a distance of 2 meters from the mirror. And this lower edge of the plane mirror is at a height of 6 meters from the ground. Now the question is, up to what maximum height and minimum height a person can see the image of tip of this pole in the plane mirror on the same horizontal line when he is standing at a distance of 4 meters from the plane mirror. So he is at a distance of 4 meters from the plane mirror. So I repeat once again this point. Listen very clearly. So there is a plane mirror of length 2 meters and a pole is of length 4 meters. A plane mirror lower edge is at a height of 6 meters from the ground and the pole is keeping parallel to mirror at a distance of 2 meters. And the question is, up to what maximum and minimum heights the image of the object can be seen. Which image? The tip of the pole. Its image can be seen in the plane mirror for an observer who is standing at a distance of 4 meters from the plane mirror shown in the diagram. Right? Let us find this. First of all, from the top of this pole, it's very clear it is the remaining distance is 2 meters. Okay. Now light incident on this lower edge undergoes reflection. Right. This is angle of incidence. This is angle of reflection. This is reflected ray. Now one more ray incident on upper edge undergoes reflection. right? These two light rays are extended back. These two are extended back side. These two are extended back. These two are meeting at this level. This is image. Okay. Now, this is 4 meters. So, image is observing on the same horizontal line which is passing through top of the pole here, image. Now, what is the maximum height up to which he can see? What is the minimum height? So this is maximum height. See, this is y max. This is y minimum. Okay, right? For this, let us consider first of all this part y1, and this is y2. Y1 is from similar triangle concept. This is I, this is y1, and this is 2 meters. This triangle and this is big triangle, similar. Therefore, y1 by total distance from here to here. This is 2 meters and this is also giving total 2 meters. Distance of the object equal distance of the image. This is from here to here 4, from here to here 4 plus 2, 6. y1 by 6 is equal to y1 by 6 is equal to 2 by 2. 2 gets cancelled. y1 is giving 6 meters. And 6 meters from where? From here to here 6 meters. And from the ground it is y minimum. Y minimum up to which you can see the image. Y minimum equal to 6 plus, or that is y1 plus 4, which gives us 6 plus 4, which is 10 meters. And one more point is maximum, or to maximum height you can see the image. Maximum height for which, again, this is one triangle, this is another big triangle, these two are similar. Again, the ratio of their corresponding sides, y2 by 2 and 2, 4 meters is equal to y2 corresponding, this is 6 by, from here to here 2, y2 is equal to 12 meters. 12 meters from here to here, but from the ground it is y max from the ground, that is y2 plus 4, which gives us 12 plus 4 and 16 meters. So this person can see the image on the same horizontal level which passes through the top of the pole, who is standing at a distance of 4 meters. Up to maximum height you can see 16 meters, and the minimum height, that is 10 meters. And 10 to 15 meters you can see the image of this top of the pole in the plane mirror on the same horizontal line. This is also very important question. Okay.